Cuprobraze is a breakthrough technology for producing heat exchangers. Since its invention just a few years ago, it has moved quickly from the laboratory to the production line. This advanced technology has led to the development of a new generation of heat exchangers, now being mass-produced around the globe. Cuprobraze replaces soldered copper brass and brazed aluminum products in radiators, charge air coolers, oil coolers, heaters, and climate control products. Its revolutionary shift is inevitable. The high thermal conductivity and the high strength of copper is superior to aluminum. Cuprobraze products include heat exchangers for heavy-duty highway trucks, off-road vehicles, and stationary generators, as well as heat exchangers for light trucks, SUVs, and passenger cars. Advanced truck radiators made by the Cuprobraze process are smaller in size and more durable than conventional truck radiators. Advanced charge air coolers can also be made by the Cuprobraze process. These are uniquely qualified for use in clean diesel engines, where underhood temperatures exceed 200 degrees Celsius. These charge air coolers can take the heat. Unlike aluminum, they retain their strength at elevated temperatures. For Cuprobraze to succeed in the marketplace, it has to succeed on the factory floor. Running at full capacity, a high-volume production facility requires the assembly of hundreds of heat exchanger cores per day, which in turn requires the fabrication of tons of brass tubes and copper fins. In a radiator, engine coolant passes through the tubes. In a charge air cooler, hot compressed gas from the turbo compressor passes through the tubes. Advanced heat exchangers use flat tubes, which maximize the contact between the fluid and the tube walls. Tubes are made from a special, anneal-resistant brass alloy, which retains its strength after brazing. Using a variety of techniques, brass strip can be fabricated into tubes. One method for making tubes is high-frequency induction heating, or HF welding, which can make tubes with a wall thickness of 110 microns or more. HF tubes have no irregularities at the seam, which can be advantageous when assembling the tubes into cores. Here, special machinery forms the strip. The tubes are then cut to length in the same machine. The cut sections of tubing are lined up in preparation for spray coating with the brazing material. The brazing alloy is sprayed onto the external surface of the tubes using a tube spray application machine that ensures process uniformity. Once the tubes are sprayed and the coating dries, they can be transported to the assembly area, where tubes and fins are put together into cores prior to brazing. Copper fins are essential to the operation of advanced heat exchangers. Their high thermal conductivity and great strength allow for the fabrication of much thinner fins than aluminum. A corrugated fin machine converts copper strip into fins. A variety of fin designs can be fabricated, depending on the application. The fins are cut to length and collected into trays. Trays of fins are stacked on a cart for transfer to the assembly areas of the plant. Typically, a heat exchanger core is made from fins, tubes, side supports, and header plates. Folded fins are inserted between the tubes. This step can be accomplished manually or with the assistance of semi-automated assembly equipment. The tube ends of the tube fin assemblies must be inserted into holes in the header plates. These plates hold the entire assembly together. Again, specialized machinery simplifies this process. A crucial step in the entire manufacturing process is the application of the brazing slurry around the holes in the header plates, which hold the tubes. The quality of the tube-to-header joint plays a pivotal role in the longevity of the heat exchangers. This production line includes 2 header plate slurry application machines. The heart of the Cuprobraze production line is the furnace. This is where heat exchanger cores are brazed in a nitrogen atmosphere. A continuous belt furnace allows for very high rates of production. Here, the heat exchangers are loaded onto a moving belt. This furnace is sized for brazing at rates of 1,500 kilograms per hour. It has a 1,200 millimeter wide belt and a 350 millimeter pass height throughout the furnace. An automated control system allows for flexibility when brazing parts of different configuration and mass. Given the loading and speed, the furnace's 4 zones of temperature control are preset to give fast heating to a peak temperature within the core of 650 degrees Celsius. This furnace has a nitrogen convection cooling section that cools the parts to 150 degrees Celsius. Nitrogen convection cooling gives the product a bright appearance and allows the overall length of the furnace to be shorter. The Cuprobraze process nears completion with the emergence of brazed Cuprobraze heat exchangers from the furnace. One advantage of the Cuprobraze process is that it is much more flexible than an aluminum brazing process. A wide variety of products can be processed on the same high-volume production line. This flexibility, plus high capacity, is especially important to the makers of trucks and off-road vehicles.